been a request to do post-lab 2, problem number 3, and it's a tequila alcohol problem, and it says it contains 40% alcohol by volume. Now, interesting fact is that the proof of an alcohol is twice the concentration of alcohol. So this alcohol has a density of 0.812 grams per milliliter. So density. And then calculate the mass. So we want to find the gram weight in that, in some given volume, obviously, because we're going to have 2 out of the 3 variables. So mass in grams is our question. And then a 5.0 mil shot of tequila. All right. Back in my day when I was coming up, they only had a few different tequilas. Now there's a plethora of tequila. And you just say a name and you can get one. Hornitos, for example. I don't know. We only had Cuervo and Cuervo Gold. That was it. And then off brands. Okay, so 5 mils, that's what stands alone to me. That's the volume, right? So we have a volume of 5 milliliters. We're going to, write down, very first thing we do is density equals mass over volume. We want to calculate the mass, so we have to manipulate the equation. Again, we've done this previously, but let's do it one more time. We're going to multiply both sides by V, because that's the same as multiplying by 1. Now the V's cancel, and we're left with dV equals M. All right? So we're going to multiply the density times the volume. So here we have, let's do it down here below, 5.0 mils times, and we could do this without even really looking because we only have 2 numbers, and we have to eliminate the milliliters, and milliliters are on the bottom. Remember, anytime you have a ratio, you can use that ratio in either direction. We can either write it as 0.812 grams per milliliter or 1 milliliter, 812 grams. But in this case, we get to use it straight as it was presented as the density. Now milliliters cancel out. We plug that in our calculator. 5 times 0.812. And our answer is 4.06 grams. Remember to do the sig figs. This is a ratio, so it's an exact number, so it doesn't figure into our calcs for sig figs in this class. Specify this class. 5.0 then is 2. We need 2 significant figures. So we look at 1, 2, and then we look at the next number that's going to be dropped. And if it's bigger than 5, we round up. In this case, it's 6. So we round up to 4.1 grams, and that's our reported answer. Right? If you get here, you're going to get most of the credit. Right? So, but what we want to do is we want to get used to just trying it. So if you have this answer, that's probably going to be close, but this is exactly what we want. So if this was a 5-point problem and you got here, depending on how, if anyone got this, you might get 4 or you might get 5. But get to here at least, and then leave everything in your calculator until you get to the end and then make the cut. Do not make cuts before you get to the end of the problem. All right, so in this problem, this is post-lab 2, problem 4B. We've already solved the volume for this problem in part 4A, and now we're going to look at what the radius is. And we do that by taking the equation of a sphere, which is 4/3 pi r cubed, and then solving for r. All right, the first step is to move the 3/4 to the other side and then multiply. And you're also going to move pi to the other side. And that leaves this with r cubed. So when we put that in our calculator, I would do, a lot of people would do the 3 divided by 4 times pi first, or I mean divided by 3 divided by 4 divided by pi, excuse me. Or they could do it before, you could do it before you move it either way. 3 divided by 4 divided by pi, shift pi. There we go. And so this whole series right here is 0.2387. And then we're going to multiply that times 4.25 times 10 to the 39. Now remember, whenever we enter a number in scientific notation, we put brackets around it before we put it in our calculator. It's good practice and it works every time. And because some calculators do it automatically, but not all calculators, and even ones that do it automatically sometimes get confused. So I'm gonna now multiply that by 4.25. Again, minus 39. And it looks like this when I enter it, right, in brackets. And then the answer comes out here. 1.0146 is as far as I'm going to go. All right, so I'm going to write that answer down. 1.0146, well, I'll just put it all down, 127, times 10 to the minus 39 equals r cubed, right? And remember, this is a volume, so this is centimeters cubed. I didn't put that down in the original, but that's what it is. All right, so we're at centimeters cubed. Now we're going to take the cube root. A little trick to make sure you know you're getting close. Cube in exponents and roots, you divide by this exponent, you divide this number, so it should be somewhere around minus 13. That's what we're hoping for. And let's see if I remember where the cube root is. And so when I do that, I get 1.004 times 10 to the negative 13. Centimeter, right? Because every time I take it apart, I'm losing one value. And a radius is just a length, so the units can't be cubed. The units are a centimeter. Okay. So there you have it. Okay, so part 4C in this problem, we've gone from determining the volume in A, the radius in B, and now we want to change the radius from centimeters to nanometers. Now, there are all kinds of ways to make this conversion. My preferred way is to go from centimeters to meters to nanometers. If you have a different method and you can get there correctly, then that's just fine. This is for people who need another method, right? So when I take these problems, I don't even look at the decimal or scientific notation. I just look at the units. So I start with the units. I want to go centimeters to meters. So I find my conversion. 1 meter is 100 centimeters. And that's on my conversion chart on the back page, right? Under prefix definitions, centi means 100. Then I'm going to go from centimeters to nanometers. So, I mean, from meters to nanometers. And I know that 1 meter, excuse me, is 10 to the 9th nanometers, right? A smaller number needs a whole bunch to make 1. Just like a bigger number needs a whole bunch, it needs a lot less, like a portion of it, less than 1 to make 1. So for a small number, you need a whole bunch of them. So 10 to the ninth there, 100 here.